Hi everyone. Today we'll be learning about the engineering and installation of microwave equipment. According to their usage scenarios and forms, microwave equipment can be classified as full indoor, full outdoor, and split. Split mount microwaves are most typical as they have a wide range of uses. Compared to traditional optical transmission equipment, split mount microwaves have an antenna, ODU, and other outdoor components. This allows it to transmit and receive microwave signals and process RF signals. IDU is the indoor unit that processes IF and baseband signals. It connects to customer-side devices via E1, GE, FE, and other interfaces. IDU and ODU are connected by the IF cable. Due to the antenna and ODU, outdoor work accounts for a large proportion of the installation workload, which depends on the environment and the types of devices. An important factor affecting workload is the antenna diameter. Antenna diameter also affects delivery costs and lead time. This is why projects generally control the use of large diameter antenna. Microwave equipment installation can be quite flexible on towers, roofs, or poles. Take a look at this diagram on the right of a typical installation process. After installing the hardware, the next most important step is to align the microwave antenna. Why must we do this? Take a look at the diagram below. From here we can see that antenna radiation distributes energy intensity differently in the air. The direction of maximum radiation is called the main lobe, while the other lobes are called side lobes. The antenna is aligned when the main lobes of both ends of the antenna line up, resulting in maximum signal strength. Antenna alignment isn't too difficult. All we need are some binoculars to roughly determine the position. Then, using the wrench, fine-tune the horizontal level and pitch angle of the antenna. The multimeter is used to test the reception level. At the maximum reception level, the main lobes of the antenna signal are aligned. That's all for today. Thanks.